Hello.
Hello.
Hello. Can
Hello.
you hear
Hello.
my voice?
Hello, Mr.
Hello.
Yamamoto. Yes, you're audible.
Okay.
Hello. Hello. Hajimamaste.
Hello.
Hello.
はじめまして。Hello.
Hello.
Can you hear my voice?
Yes, I can hear your voice.
Okay. Thanks. Sorry for it. I
Oh,
misunderstand my time zone. Yeah.
no issues. I saw that there is a time lag of 3.5 hours. That day we had a
Oh,
misunderstanding of 4 hours. So that's something that
okay.
I checked today. So how are you? How are you?
It's just my so I am fine. That is my just finished my working at my company. Yeah.
Okay. So I think we have seen the questions, and I saw that you were on the fifth position on the Shopee competition, and I saw your code and
Yes.
I saw your
Okay.
work also. So congratulations on that.
Thank you.
And I also saw that you are very regular on the Kaggle notebooks. I
Okay.
saw your other works also. I have read of your other interviews also. So
Yeah, but that's not book. So it's dirty code. My many experiment in this notebook and modified many commits in that convention.
okay, okay,
It's many commentators comment command code in this notebook.
okay, okay. So let's get to your introduction. Like, I'll want that you introduce yourself, your basic area of interest, and how you got into data science.
Hmm. Okay, uh my introduction. You like?
Yes,
Yes.
introduce yourself and
Okay.
how you got into data science. What you were
Data science.
interested
Okay, okay. So I'm Hiroki Yamamoto. So now I work at the Acroquest Technology as a data scientist. So image processing or NLP or as a tabular data is also on. It's and also I will consult with other companies data science or to improve machine learning accuracy or improve control deployment or something so on. And my career journey is before seven 7 years. So when I was a graduate student, um, I studied about image processing or image processing. So I so I try when I try to so join competitions about maybe plankton classification plankton
in? Okay, okay,
competition in Kaggle competition. Uh, I I use the GPUs and it's try classification. It's the first my Kaggle competitions and it's very interesting and interesting competition. So after about 3 years, I get I uh, I get gold medals in IEEE compet camera competition.
okay,
It's a very great competition, and that competition is that classify about take classify the camera using to use the
okay,
picture. But yes, and after I join many competitions. I get four gold medals, and I become a grandmaster. It's
okay,
happy. And in my career journey, I think its most interesting competition is a shopping competition. It is a very great, it's a very interesting competition. Uh, this competition data have two domains. One is a text, one is images. This competition this competition objective is two group なんだろうな、two group プロダクト。 products.
Okay.
So yes, uh, for example, it have a so one is a camera.
Okay. You took the images
Camera
from the
integrate.
camera and then tried to classify.
Yes,
Okay.
classification. Yes. So uh, camera and find same cameras. Yes,
Okay.
same cameras using these data. It's very good. It's a so very great compression. Um, so in this compression, I tried so many retrieval methods. For example, generalism and many backbone networks. For example, efficient net or ResNet 200 dimension,
Okay. So
200D.
mostly use
Uh,
transfer learning techniques from the
yeah,
other
yes, yeah,
pre-trained
yes,
models.
yeah, yes.
Okay.
Okay. And search part, I use um, database augmentation. Database augmentation.
Okay.
I Yes, it's used by many retrieval compression, like Google landmark compression. Yes, and also we try to filter
Okay.
about yes. We extract many pairs in uh, many pairs who are getting us a candidate. Yes, such as many in this compression, and some data have also many same content, same text, but it's not images. But image is not same.
Okay.
It is a yes. It is a not same product. It is a not same product. So sometimes uh, only search, only search. Only search we find these data. So after we can filter and filter, we can apply to filter for more accurate, getting more accurate accuracy.
Okay. And one
Yeah.
more thing that I saw that in your notebooks, you preferred PyTorch over TensorFlow. So any reason
Yes,
behind that?
yes, yes.
So
Mm.
so any reason for your preference of PyTorch rather than using TensorFlow?
Yes, PyTorch have a very great pre-training libraries.
Okay.
Like yes, it it's called TIMM.
Okay.
TMM library. TMM library have many so great libraries. So ResNet, like ResNet or efficient or swing transformer or other uh, and VIT or something like that. So maybe many Kaggle competitors use this library for uh, more getting pre-training. Yes, I I think that's a great library for.
Okay.
Hmm.
Okay. Before getting to the next question, can I ask Mr. Yamamoto, can you increase the volume, like if you have from your side,
Okay.
a little, just to be a little more clear?
Mm, okay. Mm, okay.
Okay. Okay.
Okay. I see. I
Okay.
just
Okay.
increase.
Okay. So, as you said that you have spent 7 years on Kaggle, and now you're a
Yeah.
grandmaster. So, what are the problems you majorly face while data cleaning and data pre-processing? Like real world data is not so clean as we expect
Yes.
it to be. So, what are the experiences that you have gained while data cleaning, and what problems have you faced?
Okay. Data cleaning is very great. It's very difficult problems. So in Kaggle is also in Kaggle, many data is almost clean.
Okay.
But my working. So data scientist is very have try treat many not cleaning data. Yes, and also so I think Mm, I try in my working. I try to many hand labeling data. I sometimes I use hand. I my hand labeling, so to watch data, or also I find many problems and report to the customer.
Okay.
And also, yes, also I, so my experience is many hand labeling, or also I will check about data and also as a consult customer, and also customer, sometimes customer will so increase new data, get new data, or clean, or so to consult discussion about the data domain, this data noisy also.
Yeah.
Yeah.
Okay. So, can you just like you were talking about customers? So, can you take us through the some of the business constraints that are present in machine learning problems? Like in the Shopee competition, you must have seen that the results should be coming out very fast. Like you should not be having a lot of delay, so that customers don't have a bad experience on the platform. So similarly, you are working in a company, so you must have seen a lot of customer requests, which are generally mathematically a little bit difficult to digest, and you cannot explain to them that what is time constraint and like it's taking more time to train, but you have to deal it with yourself as a data scientist. What your experience has been with business constraints that you have seen all over the
Yeah.
time in companies.
Mm.
So what your experience regarding the business constraints? Like I read your interview that you are also you consult with other companies also. So
Yeah.
there's a difference that customers don't understand the mathematical constraints of a model, and you have to
Mm.
like
Yes, yes.
do you perform the
So
changes
that's
from your side rather than you can explain them. So where you have faced these problems and over the last years that you've been working. So can you take us to that?
yes, my customer have two types. Yes, as you said. So one is a research problems, or one is business problems. Yes, research is I can many develop. Research customer is many they have they have problems or thesis, or customer have a thesis, or problems.
Mm.
This I try to solve these problems using machine learning, and it is very simple simple solution, or it's a simple solution, but its business customer is very, I think it's very difficult. So business customer have in business customer have don't always to more increase accuracy.
Yes, yes, yes.
Yes, so it's uh, algorithm. Sometimes customer so explain customers customers have a question, that is why machine learning
Yeah.
predict that why machine learning prediction over the result. So it is very difficult problems. Um, so I think it, its situation, I tried selection about selection machine learning. So I can machine learning selection that I can that this algorithm can explain about this, some like decision tree or random forest or other exhibits. Exhibits, this three algorithm can explain
Mm.
the why its model can why its
Why it is
model
giving a
output.
certain output.
Yes,
So
yes,
it's sometimes
yes, yes.
difficult to explain it.
Yes, maybe experiment. So it's a situation I cannot apply deep learning algorithms.
Mm.
Many deep algorithms cannot explain.
Yes.
Yes, explain. So it's not up. It I cannot apply.
Mostly customers
The,
prefer a decision tree as simple something as
yeah,
a
yes,
decision tree that I can make
yes,
if else and explain
yes.
to them.
it's good. It's a great algorithms. Yes.
Okay,
Mm.
so next I would like to ask that how much mathematics do you think is important for a data scientist? Like research work is there, engineering is another domain. So how much do you think that a good data scientist should know in detail about the algorithm? Like you were talking about neural networks. So there are a lot of concepts like backpropagation, the weight updates are there, momentum is there. So how much do you think the depth of mathematics should one know as a data scientist? And how you started as your journey?
I think I use many mathematics skills, so linear algebra or so probability or other things. But I think it's not. I think it's not too much. I think not too much
A
for
balance should be
linear
there.
algebra. Yes, yes. So of course, mathematical skills is higher. Is I think is more better.
Yes,
But
yes.
but yes. Uh, but at least I think it's two objects so subject. I it's must two subject is needed. I think yes. Hmm.
Okay. So next, I would like to ask that suppose you have a new data science problem, or like you want to solve it. So how do you start to approach, like looking at the data, which models to use? And I read like one of your articles was there, and you said that you used as ensemble models for Kaggle competitions generally.
Competition. Yes.
So
It's approach.
how would you like look at a data science problem? How do you decide the algorithms and all the like whether to keep simple decision trees, simple random forest, or when to turn to a neural network? Like when the complexity is enough that we can turn to a neural network.
Yes. So in Kaggle competition, it's not many in Kaggle competition. I try first small neural networks um, because so in Kaggle competition, so I cannot we can we don't need to explain uh, about
Yes, yes, because
the
there's no
explain
customer over there. Yeah.
yes, don't need result many use a PowerPoint or but Kaggle compression is needs more accurate only. Um, so I try and it depends on compression. In so for example, image processing compression, like as Google landmark or other things. I at first, I try to small pipeline,
Okay.
small pipeline, more lightweight backbone or lightweight data or lightweight so lightweight small epochs or not regularization tricks like mix up or cut out or other tricks. These tricks are very coverage is very slow. It's yes. So first small benchmark creates almost uh, small benchmark small benchmark uh, for so because a small benchmark pipeline is best it can be it can be many experiments. For example, accelerated B7 is very huge networks, but its network in experiment, its network used to very long training.
Yes, yes, yes. Because
Yes,
even if you have to change the hyperparameters, anything that again you have to start again once again.
yes,
And
yes,
I think there's a limit over Kaggle, right? That the hours
yes,
you're there. So do you have GPUs at
yes,
your local system also? Like, do you use local
yes.
training?
Yes, local training uses many limited resources.
Okay.
So yes, yes. It's small. If small models, we can use many new tricks apply
Mm,
the
yeah.
data. So in I use many bigger models and use mini regularization tricks and so on. Lastly, I update Kaggle notebooks, and this model use many run and check the validation or and public and private readable. Yeah.
Okay, so how do you decide the performance metrics? Like performance metrics play a very important part in like deciding how good a model is. So suppose we are considering imbalanced data set, like any medical competition is there, like we have to find whether cancer is present or not. So these competitions are generally we get an imbalanced data set, like the positive case is very
Yeah.
less and negative case is very large in large amounts. So how do you decide a perfect performance metrics? Because accuracy is not a good thing to look at imbalanced data sets while we are making model. So how do you decide the performance metrics?
In business or in Kaggle?
In You can explain on both sides because I know that once the customer gets involved, the entire story is different because you have to make a model which is explainable because in business presentations, and in Kaggle you just have to
Business.
get the good score.
Yeah. Yes, Kaggle score is already evaluation metrics decided. But so business, yes, business situation. So I discuss about customers for customers. So objection or machine learning objection or system requirement or other things. So I I I think so these I think these content. So if so if miss if missing if customers deduce missing content in anomaly detection, we can we I need to apply so F1 or
Mm.
recall. And also uh, also other situation, so time series so prediction. uh, I if customer have so uh, not if customer don't have if customer need to so reduce the cost, I think so apply a regression uh, evaluation function like so RSME or other
Mm.
things. Mm. It depends on customer situation, I think.
And in your recent notebook that you have posted that you got the Shopee thing, I saw that you used QML, like the library
Yes, yes,
for machine learning.
yes.
So how has it helped in optimizing the training times? Because I have done a little CUDA programming, and I see that in the tutorials I saw that it increases the parallelization in the calculations, and the training time is
Yes.
drastically reduced. So what was the amount like? Was it a drastic reduction in the time using QML, or
Uh, yeah, QML is very great libraries.
okay?
It yes, its objection is so not training cost reduction. It's it's only calculate. It's very fast calculation for embeddings. Embed, embeddings distance.
Mm.
K nearest neighbor. Yes, K nearest neighbor is very high cost computing. So, but its Shopee comp is very limited time.
Yes.
Yes, we need we need to calculate faster for so many apply and algorithms. So QML is our algorithms in our notebooks. Maybe QML is used for XGBoost or nearest neighbor. XGBoost is slow, uh, slow algorithms, the light GBA, but it's uh, QML is very faster. Mm. I I think it is it's very QML is our QML become our notebooks
Yes.
is very fast. Yes.
So till now, you took us through image processing problems that we have faced. So can you take us through one natural language processing business problem that you have faced, in your journey? Like a customer came up through like text classification, document classification, and how you tackled that purely natural language processing. Like if you have used transformers, BERT, whatever things. So how you tackled from data cleaning to, because text is generally rather difficult, more difficult than the other general problems because of
Uh,
multiple sequence possible answers are there. So how you tackled? Can you take us through a NLP project that you have done, a business problem case?
yes, NLP problem is many. I tried many problems. I tackled NLP problems in Japan, and it's very difficult. It's very difficult. So because mm, but is very great so transformer algorithms in commonly used in NLP. But so some but is not so pre-training models, but it's not many pre-training models in Japan.
Okay.
It's a robot or this robot have so other language in English is very great, and I I have a use for Kaggle compression in this, but transformer algorithms maybe only part in Japanese is in Japanese models.
Okay.
So it's very difficult. But so advantage is many is one of the advantage is so pre-trained
Okay.
for many documents is so I think uh, it's difficult point I think. Yeah.
Okay, so like I was using a Japanese to English translator before the
Yeah,
meeting.
yes.
So how do you think like comparing, like I'm making a neural translation when it's something like French to English, and when I compare it to something like a vast language like Japanese or Chinese. So what do you think the output size increases, everything, and the parameters should increase, the training time should have increased. So how do you handle that? Like local machine or cloud? Like now you can have Google Colab Pro also, and there are various cloud platforms also. So when you started, how you managed this and like training neural networks on your system?
I use two mas I have a two mas I have two machines.
Okay.
One is RTX 3090, and
Okay.
also
RTX
yes,
3090.
and
Okay.
2090, yes, and 2080 Ti,
Okay.
and I have two machines. So I use I in convention I use these machines,
Okay.
these two machines, and also sometimes I use the so Google Collaboratory. It can be used for TPU.
Okay. Tensor processing
Yes,
units. Right.
yes. This TPU is very fast. Huh?
Okay. So
Yes,
do you
TPU is
have any
very.
TPU hardware also? Because I don't think that I have never seen a TPU hardware thing. Like at most I have seen
Yeah.
GPUs as hardware. Google provides TPUs, but I've not seen it like, and none of my colleagues also, they don't have hardware TPUs. Like they use it from cloud services only.
Yes, Google only, but
Hmm.
PyTorch can PyTorch can use this TPU for PyTorch XLA. It it its library so opens the example
Okay.
to example that example is um, Disney to 18 and train Cypher 10, Cypher 10, Cypher 10. But so many competitions is also similar pipeline.
Okay.
um, we can uh, we can use a competition in we can use these so hardware in competitions.
Okay. So over the
It's
years, you must have deployed also a lot of machine learning, like running on running platforms, models that you must have deployed. So, what
Yes.
are the things that a data scientist should be aware while he's deploying the models on the server? Like, what is the procedure? Like, do you use Amazon services or Google Cloud Platform? And what are the things that you need to create before running and testing the model? Like, it's okay. That's one thing to train it on your local system, and then it's other to deploy it and then test it on the running server. So, what are the tools and what do you think like a data scientist must be aware of before he wants to like able to deploy something on these running server?
Deploy means server or systems.
Yes, like you want to deploy it on the like you're working for a company and he has asked you to like he wants something on his website, a feature on his website. So you have trained it on your local system, and that suppose his website is hosted on Amazon services, web services. So what is the procedure
Yes.
like the creating and on transferring the code to Amazon Web Services? So what are the skills that a data scientist should have?
Okay. I see. I think so many uh, deploy system is deploy system is so many types of deploy system is there, and but so I think uh, one is so I use two types. One is also local systems. One is
Okay.
also cloud systems. I I have also AWS machine learning specialty,
Okay.
and I can
Okay.
use
Okay.
the collab. I also I sometimes I use SageMaker.
Okay. Amazon SageMaker.
Yes, yes, Amazon SageMaker. Yes, Amazon SageMaker have a great pipeline, great deployment, great pipeline. Also train and pre-processing, train and deployment. So
Deployment.
control. Yes, yes, and model versioning or watch the metrics, like input validation and or so on. That's a great that is a great services, I think. uh, means cloud AWS support these process. So developer cannot create these systems. It's very comfortable for me. And also one is local system. Local system have many almost I think batch systems. For example, in daily create many daily data. So I apply these data. I prediction these data. What is but it is very great. But the cloud system is very also more better. I think.
Okay.
Yes, that's performed prepared many comfortable function functionality. Yes.
Okay, so till now we have talked about how professional should be and like how someone who has already been into various competitions should tackle a problem. So now let's go to someone like who is just beginning his data science journey. So what would your advice would be like someone who is just joining his graduate school and he's wanting to get into data science and machine learning. So how would you like if I ask you to mentor someone, then what your approach would be for that newbie student?
More beginner, to
Beginner,
beginner, yeah.
absolute beginner.
Okay, okay. Okay. Hmm. It's I think so. Hmm. I recommend joining a Kaggle or tutorial. Main one the join a Kaggle is I think one of the methods, but also now many researcher or other competitors or other machine learning engineers can open the videos, great videos or great lectures like Stanford or other thing, Stanford or other university. So they beginners watch these videos for build many basic skills. It I think is better. And also, Kaggle is very interesting. So experiment. It video cannot also handle can be in video is but great, but it's uh, we so attendee cannot think the problems or
Yeah.
only solve the
Yeah, just spoon
problem.
feeding is
Yes,
there over there.
yeah, it's only solve the problems that teacher
Hmm.
take. Teacher take, yes. But Kaggle is many uh, very great experiment platform in for modeling. So for example, Shopee competition. Shopee competition. So many competitors open the code,
Okay.
code or EDA or other uh, data science techniques in uh, Kaggle platform. And also, its competition join if the competitors competitor objection is win, so they think many experiment uh, or model changes or new techniques or other methodic training or other things. They research the thesis or other previous previous similar competition. So it's a very great great experiment for attendee attendee in Kaggle convention. I think.
Yeah, one of the biggest mistake I made, like I think newbies make, is that they directly call the libraries. They don't understand what's happening behind the libraries, and they just get the output, and they think that they have understood that. This is something that I used to do in my earlier days. So I think I have asked all the questions, and like you want to conclude something, like anything that you want to say from your side to the people who will be watching this video, the newbies, and someone who are already data scientists. So something that you want to say from your side. Something that you want to say from your side as a concluding statement to everyone who's watching this video, will be watching this video, the data scientist and
uh,
new beginners.
how what kind of what yes, video is maybe beginner's video is maybe can almost data scientist open. For example, Stanford University has opened the easy video, introduction videos,
Okay.
and uh, also some some international companies
Okay.
open the tutorials. Tutorials is a very great content. So if they don't have don't try many don't know many model or other techniques, this this tutorials this tutorials is introduced history uh, before for example before the 7 years she opened the AlexNet or
Okay.
DesNet or EfficientNet or SENet and other history. It's a very great content, I think. Yeah.
And one last thing, that what would your advice be to someone who has already completed his undergraduation and wants to pursue a master's in data science? So what your advice be to be for the student who is like just completed his undergraduate and is now looking for opportunities in masters in data science or deep learning, artificial intelligence? So what, any tips from your side?
So sorry. Question is what is uh, great master's engineer? Is your question?
My question is that someone who has done his undergraduation, he's completed his, and now he
Okay.
wants to do masters in data science, like higher education. He wants to go for higher education, and particularly in the data science field. So, what would your advice be? Like, you have been in this field for a very long time, like comparison to someone who's just starting. So, I think your advice would be very helpful for those people.
Uh, what? Mm, it's very difficult question. So, because how to become a great. grade or master for data scientist. So I think I we need it need to continue studying, continue studying. Uh, for example, I so I just become a grandmaster until 7 years, and it's while it's it's but it's always study about the competitions and did so many solutions or other things. I I have many experiments in the competition and problem types or other thing and problem types.
Okay.
So for problem types, so I get theory in theory of method and problems in so for from some problems. So for example, if I if in business if I search the new images to use uh, in, input to input images. For example, if you input the image to new these customers want to new search new similar images. So I think so. I don't research about search about this. I I always know use metric learning such as triplet loss or other arc phase or other curricular phase as other things. I know. So I suggest this method in method for these problems. Yes. So so think so. So I need to so we need to study continuously study to new method or new uh new method or continue join the Kaggle competition. It's 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 yes, continuous studying is very need. I my my important point is continuous studying. Yes.
Okay. Okay, Hiroki, it was a very nice experience talking to you, and like I love
Yeah.
the way you shared your experiences, and you're certainly a person we should learn from because someone who's a grandmaster and you're very down to earth
Yes.
person, and it was like extremely good experience meeting. Okay, so I had a little experience in Japanese. One of my friend like he introduced me to Japanese, so I can introduce myself like watashi wa Siddharth is like I can like a little amount of Japanese. So okay, really thank you for your time that you have invested
Yeah.
to us,
Yes.
and
Thank you for interviews. It is very very interesting interview. But I'm very excited. Thanks.
okay,
Yeah.
okay, okay, okay. I'll be